Most people think grounding exists purely to protect against electrical shock, but the National Electrical Code lists 5 specific reasons for it, and shock protection is only part of the story. I'm Norman Varney with AV RoomService. I've designed hundreds of acoustical and electrical systems for critical listening and viewing environments around the world. And this series is about grounding explained. Quick, easy, simple breakdowns of how grounding really works. And today we're talking about why ground systems and circuits. In this installment, we're breaking down NEC Section 250-1, which lists 5 reasons systems and circuits are grounded, and why keeping your overprotection fast and your power clean matters as much as keeping people safe. So this probably should have been the first installment in the series. I didn't realize that there would be so many questions about this particular topic, why we ground systems and circuits, but I want to make sure that we've got that clean and straightened out early on in this series. So why ground systems and circuits? The first note in Section 250-1 lists 5 reasons that systems and circuits are to be grounded. The first 3 are limiting voltage due to, number 1, lightning, limiting voltage due to, number 2, line surges, and number 3, limiting voltage to unintentional contact with higher voltages. And then also, number 4, stabilize the voltage to ground during normal operations. And number 5, facilitate overcurrent device operation in case of a ground fault on a solidly grounded system. It further states, equipment grounding conductors are bonded to the system grounded conductor to provide a low impedance path for fault current that will facilitate the operation of overcurrent devices under ground fault conditions. In addition, we ground conductive materials enclosing electrical conductors or equipment. The code lists 2 reasons for this. 1, to limit the voltage to ground, and 2, to facilitate overcurrent device operation. But there is a third reason: to drain leakage and or static electrical currents to ground. An example would be grounding the shield of a shielded cable, which helps reduce electrical noise. Such noise can cause problems in sensitive electronic equipment, cause data errors, even audible interference. It's a misconception to think that grounding is only for the purpose of maintaining everything at ground potential to protect people and equipment against electrical shock. It is just as important to plan to help the overcurrent protection device to operate as soon as possible and keep electricity as clean as possible. A breaker or fuse that clears a fault in a fraction of a second limits how long that fault current flows, which limits heat, arcing, and damage to conductors and connected equipment. And in critical listening and viewing rooms, that same low impedance ground path is what keeps electrical noise from finding its way into your audio or video signal chain. Grounding done right isn't just a safety requirement, it's a performance one. So grounding isn't just about safety, it's about giving fault current a fast, clean path home and keeping your system quiet along the way. In the next video, we'll ask, what is effective grounding? If you're planning a critical listening and viewing environment and want acoustical and electrical designed right from day one, book a call with me. There's a link in the description below. See you in the next video. Thank you so much for watching this episode, and if you would like to see more, click here or here. And don't forget to go to avroomservice.com to see how we can help you make the most of your listening experience.